afternoon. Today in our video we are going to look at a simple experiment, how to verify Hooke's law. We looked at the mechanical properties of matter and Hooke's law. It is very important, and how we are going to verify it. This is the setup for the experiment. We have a little distance. This is a clamp where the meter rule is hanged, and also another clamp down. Then we have the spring. The spring is the one that we shall be attaching the masses from. So we have 6 slotted masses, but each is 100 grams. And we are going to be hanging one by one. So the first step is to first read the initial position of the pointer. So I'm using this pen to act as my pointer. So I read the initial position of the pointer, which is 35.0 centimeters. So after reading the initial position of the pointer, now I'm hanging mass, which is equal to 100 grams. So let me see. So when I hang it, we can see that the spring has been displaced downwards. So when it is displaced, meaning it has extended. So we need to read the new position of the pointer. So let us read and see, and it's giving us 42.1. So we record it as 42.1 centimeters. So from here we can calculate the extension as the extension it will be equal to P1 minus P0, where P1 is our new position of the pointer and P0 is the initial position of the pointer. And this one will be 42.1 minus 35, that will give us 7.1 centimeters. That is the extension. But we need more values so that we tabulate them in the table and we plot the graph to see or study the graph very well. That will give us a good picture about the experiment to verify Hooke's law. So we are going to hang more than one masses, and this is the next one. So meaning we have 200 grams, and when you read the extension here, you first wait, don't read when the spring is still vibrating, and this one is giving us 50.3. So that is the new position. So we calculate the extension, which will be now equal to 50.3 minus 35, and will give us 15.3 centimeters. So we put another one. So we read the extension, and it is giving us 59.4. So 59.4 is the new position for 300 grams, and we calculate the extension here, which will be equaling to 24.9. Then we put another one to make it 400 grams. The extension produced is 68.9, and the new position is 68.9. Then the extension produced is 33.9 centimeters. You know how we are getting the extension? By getting the new position minus the initial position. So when we touch the 50th mass, we are getting the extension as 77.5. And when we calculate, when we remove 35.0 centimeters, we are getting 42.5 centimeters. So lastly, but not the least, for the 6th mass, we are getting the extension as 86.8. Sorry, the new position as 86.8, and the extension it produced is 51.80 centimeters. So in simple terms, that's how we can calculate it. Then what are we going to plot? We are going to look at it. Since we know that the force is directly proportional to extension, so we are going to have F equals to KE, where KE will be what? The spring constant. But we know that the force is equal to mg, that is mass times acceleration due to gravity. So when we substitute for mg where there is F, we are going to have mg equals to ke. So we make m the subject, then we are going to have m will be equals to k over g brackets times extension, where g is the acceleration due to gravity, e is the extension, k is the spring constant, and m the masses that we have been attaching on the spring. So we are going to plot a graph of mass in grams, then extension in centimeters. So we expect to get a straight line passing through the origin, and that one will verify Hooke's law. So thank you so much for paying your attention. In our next video, we'll look at how to plot the graph, and we talk about the graph so much. Okay, have a good day.